This is Expert Funda and you are watching on YouTube. So let's understand today that we are going to solve this Leetcode 2901, the longest unequal adjacent groups subsequence second. This is the Leetcode problem and in the daily contest series. Okay, so we'll walk through the questions and then we'll understand. Okay, so if you pause this video and if you go through the statement, you will understand clearly what the question is saying, right? So we'll walk through the question and we'll understand the statement first. Okay, so the question is saying that the difference between path and subsequence we have to understand, and then we should understand to define some DP and the previous arrays, right? And how to construct the solution using the there is a breadcrumb approach, and that we will see in this video. Okay, so let's pause this video and let's understand the question statement. What question statement is saying there? The question is saying that you are given a string array words and an array groups, both arrays having length n, right? So two things we have given, the words and the array group, right? If you remember study, we have solved 2900 Leetcode for 2900 problem, just previous the question number, right? And we have understood how the groups and the words have a relation, right? So this is just an that was an easy question. This is a hard level question of the previous question that we have seen yesterday. So let's understand this question. So what we have given in the question series, we have given words and the groups and both having the same size of length n. So next line it is saying that the Hamming distance between two string of equal length is the number of positions at which the corresponding characters are different, right? Means the Hamming distance between two strings of equal length, right? Two strings of equal length is the number of positions at which the corresponding characters are different, right? That we will see what question is saying. You need to select the longest subsequence from an array of indices 0, 1 to n minus 1, right? You understand the sequence, right? What is the subsequence, right? So what is the difference between you can say subsequence and what we call subsequence and we used to say the path, right? So don't we get confused. There is a difference between you can say path and subsequence, right? So if you talk about the subsequence, right, let's suppose some elements we have in the array. Okay, so let's suppose we have a b c d, right? So what are the valid subsequences are there, right? So the subsequences can be a c e b d, right? a b c, right? But if you talk a c and a, right, because the order has changed. What we have in the array? A, B, C, D, E. But in the sequence that we have to take is only in the what? In the increasing order or continuous order, right? So the definitions of the sequence, if you talk, is a subsequence is a selection of element from an array in the same order, but not necessarily the contiguous, right? So if you want to create a subsequence, right, that let's suppose for the array a b c d e, right, there can be multiple valid subsequences like a c e b d a b c. But if you write c a, right, that is not a subsequence because the order has been changed. Order is what? A b c d. So you can write a c e b d a b c, but you cannot write in the reverse order, right? Like c a. That is not possible, right? So that is called subsequence, right? In the graph problem, right? Sometimes it is saying the path, right? A path refers to sequence of nodes connected directly by edges in the graph. So if you move from node A to B and B to C in a graph, okay, so you can only call it a path if there is an edge. Let's suppose from A to B, B to C, right? So the subsequence and graph you should understand, right? If you understand the meaning, right, meaning, then you can construct the problem. So you understand, you need to select the longest what subsequence, right? Means from the array of indices you have given, from the indices you have given, right? Such that for the subsequence noted as I at 0, I at 1, I at k minus 1, right? And because the length is k, so we can say, we can denote these as a these things, right? Subsequence are denoted as this. So these, so these values are the sequences that we are talking about. These hold some rules, right? Let's suppose for adjacent indices in the subsequence, adjacent means just next to that, right? What is the adjacent? What is the neighbors? Neighbor indices, right? Their corresponding groups are unequal. So you can say group at I j not equal to group at I j plus 1, right? If both are not equal, means both groups are unequal, both are not equal, it should not be equal to, right? For each j, where j plus 1 is greater than 0, less than k. Similarly, words at j and words at j plus 1 are equal in length and the Hamming distance between them is 1, where j plus 1 is greater than 0, less than k for all the indices in the subsequence. So only difference in the words and words j plus 1 is what? The distance is between them is 1. Are you understanding? Right? Then what we have to do? And these two things is happening all in the indices in the subsequence, right? Then what we have to do? We have to return a string array containing the words corresponding to the indices in an order in the selected subsequence. If there are multiple answers, return any of them. So the string in the word may be unequal in length. Okay. So what the problem statement saying that you have gone through? Understand an example. Let's suppose we have given words like BAB, DAB and CAB, right? Groups are 1, 2, 2. So we have given two things, words and groups, and you have to return the array of elements in the array, right? So the explanation is saying a subsequence that can be selected is 0, 2. How? 0 and 2, BAB and CAB, because group at 0 is 1, not equal to group at 2, right? So these and these we can say the condition matches, right? Because we have already told that groups should not be equal. So the condition first is matching. Now it is saying the words at 0 dot length equal to words at 2 dot length, right? Both lengths are equal. And the Hamming distance between them is 1, because here we have BAB, here we have CAB. Means here it was B, here it is C, but the rest of the elements are same. And so the answer is saying that BAB. Words at 0 and words is at 2. You understand the difference, right? Understand another sequence. What are the another sequence, subsequence will be there? So this is the first subsequences that is possible, right? But what about the another subsequences in the array is possible? Let's suppose this time we are selecting 0 and 1, not 0 and 2. Previously we have selected 0 and 2. Now we are selecting 0 and 1. So the first condition is true, right? The first condition was saying group at 0 is not equal to group at 1. So this is condition matching. Another words length are same and the Hamming distance is 1. Why? Because words at 0 is what? BAB and words at 1 is what? DAB. So if you say AB is there, AB is there, only difference between the one string character B and D. So the Hamming distance is also matching, right? And so we can say this is also giving you the length of subsequences of condition that satisfies 2. So we can return this one also. Either you return this one right? BAB or CAB, or you return BAB or DAB, right? So any of these two subsequences are possible in this example. Now it's time to recap the given things what we have in the problem, right? So what you have given? You are given a list of words, right? A list of words we have given, and a list of you can say group or array of groups of the both having the same length. So what is our task? So our task is to find the longest subsequence of indices at the given indices from 0 to I0 to I at k minus 1. Why? Because there are some conditions we have also given, right? Based on that, we have given some conditions, right? Means our task is to find the what? Longest subsequences having the indices like this, right? Such that for every adjacent pair, for I and I at j and I at j plus 1, means this is indices at j and indices at j plus 1, means the two consecutive groups should not be equal, right? Means for every adjacent pair, their group are different. Means groups at I, j not equal to groups at I, j plus 1. Means both consecutive or you can say adjacent pair, not you can say consecutive, adjacent pair are different, right? Another, it is saying words at ij and the words at ij plus 1 are same. Means the words having the same length, right? And the third point, it is saying that their humming distance is exactly 1. Means their humming distance is exactly 1. That means only one character is different, right? And then we will return the corresponding words in order, right? So you understand everything, right? You have also understand the subsequence that we were talking about, like I have clarified that what is the difference between subsequence and path, right? So let's clear up the common confusion that we have seen in the when I was talking about the subsequences and indices. So what was the difference between the path and a subsequence? So I told you a subsequence is a set of element in order, not necessarily next to each other, right? But a path, on the other hand, is a sequence where each node is connected by an edge, just like in a graph. So in this problem, we treat word as node. That word we have given, right? These words as a nodes, right? And a valid transitions based on 3 rules, right? That we have talked about, right? So our 3 rules become an edge. These are called edges, right? These rules are, these 3 rules are what? Our edge. And so we're really finding the longest path in a graph. And then we will convert that subsequence of words. Okay? By a step, this intuition and the approach that we are going to solve, right? So first of all, we should understand the constants we have given, right? So there is a variation of longest path in a directed graph problem with a specific constants between the nodes, right? And each word can be a node, right? In the that we have given the words, right? And each word can be a node, right? And there is a directed edge from word at I to word at j only if these groups are not equal. The length should be at the words at a given indices. You can say the words length should be same, right? And the Hamming distance should be equal to 1. If we take a formula, we can say function Hamming distance, and will pass both words, so it should return 1, right? But instead of building the full graph, right, which will take a lot of memory, we only simulate the transition in place while calculating the longest path. It means you should not create the graph, means you should not build an adjacency list and those things, right? Because that will take a lot of memory. So make sure when you are writing the code, you are not going to create the full graph, right? Means you are not going to create the adjacency list, adjacency map, right? Those things you don't do because it will take a extra memory, and then you will get a time exceed limit exceptions, and then it will block, right? So just think that. So the first of all, we will understand the constant, and based on that we have to define it, right? That we'll see how to implement it. Okay, in step 2 we will define the helper method to calculate humming distance. So two strings have humming distance equal to 1 if they are the same length and differ in exactly one character. That you understood, right? Means the two string can having the distance, humming distance is 1 if they are the same length and they differ exactly one character, right? So if you'll talk about to create the function, how you're going to create the function, right? So first of all, we'll define a function. Let's suppose I'll give the Hamming distance, will provide two parameter a and b, and it will return 1 as a output, right? And this will be the helper function, right? So we'll create a private. Then we will define, first of all, int distance is 0, right? We will define a function variable. Then we'll create a for loop and we'll go through the all the characters of the first word, and then we will check each character in b. Means we will traverse. Let's suppose we have in a we have a b a, and here we have a c b, let's suppose, right? Or we have a cab and dad, that was there, right? So we'll go through all the elements from a character. We'll traverse all character and we'll check all the character in this. For this we have to go to create we have to go for the all the character elements, and for that we will create a for loop. I hope you understand, right? To check all the character, we'll create a function if condition. So words at a words at indices I, means you can say each indices will check in the a and b. If a is a word, b is a word, two words are there, right? So words at I, if words at I, words a at I, you can say character at I, if it is not equal to this, right? So we'll keep updating all those. So distance should be 1 because we have starting from 0, so only one character distance should be there, and then we will complete our for loop, and finally we'll return the distance, right? So this humming distance should come 1. I hope you understand, right? We only do what? Two strings we are taking. String is what? Word 1 and word 2. From where? The words characters, right? So we'll take two words from here, then we'll check the distance is coming 1. So how will, when it will come, if if both characters are not matching in the word, then we'll increment this, and finally we'll return this one. This is not too much complex code, just think about it. Okay, now understand the dynamic programming, right? So how we're going to do the dynamic programming? So set up a dynamic programming, right? To set up the dynamic programming, you have to define some states, right? So we will track you can say dp at I and previous at I, right? So dp at I is the length of the longest valid subsequence ending at index I, and previous will be you can say the previous index in the longest path that ends at I. It will help you to construct the sequence, right? Let's suppose first of all we'll create a dp, right? Dp array where we will store the maximum path length ending at index, right? And then we'll create previous. This is also an array. So previous index in the path will keep, right? And then we will fill the dp array with 1. So every words is at least a path of length 1, and then we'll fill the array with -1. So no previous initially, right? So these things we will do initialization of the variables in the program first, and then we'll keep writing the code to simulate the graph with nested loops. Means we are trying to next we should do what? We will avoid the building the full graph, right? We don't need to do that. See, if you not define these things initially, what you will do? You will create the graph. You have to write the you can say adjacency list, adjacency matrix, right? And then you have to do that. But if you just write these two things, dp and the previous one, right? If you initialize these two things, so you can avoid building the full graph, right? And so that we will first initialize these variables, right? We will take a dp and previous, right? So that dp at any index, right? dp at I, the length of the longest valid subsequence ending at this indices will keep here, will store there. dp at previous will store the previous indices in the longest path that ends at I. Like that, we'll keep adding that. You can see, right? We can track the state of dp at I and dp previous at I, right? You have to we have to store the dp at I, right? Means till the index I, the what is the length of the longest valid sequence. You know the valid sequence, right? I told you, like, we have a b c d, right? E. So if we will write a b a c a b d like that, right? That is the subsequence, valid subsequences. But if you write c a, that is not a valid sequence, right? So you have to write, you have to keep, you have to store the length of the valid sequence at this indices, and then you have to write the previous. Also we have to keep track of the previous indices. So previous indices in the path ending at this location we have to store, right? So let's suppose you will store the longest you can say longest valid sequence you will store somewhere, right? But how will you track the previous indexes, right? So for that you will keep track of the previous index at I, right? So you can reconstruct the state again, and you can find the valid sequences, right? So to reconstruct the sequence, right, it will help you. So this previous at I will help you to reconstruct the sequence, right? To reconstruct the sequence, you have to write the previous at I. I hope you understand, right? Let's go to the step 4. Now it's time to simulate the graph with the nested loop so that we can avoid building the full graph, right? As I told you. So what we need to do, first of all, we'll make a for loop I to n, we'll go for all the length, and then we'll go for j is 0 to I, right? So we can check the groups should not be equal. First rule, we'll check the group should not be equal, and the words at I length should be equal to words at j length. If these two things is there, then we'll check the Hamming distance, words at I and words at j is should be equal to 1. And we have already created this function words at I and words at j, right? Where I have told you this words at I is a and words at j is b. And then string a, string b, we have defined the function, and each character in the word this and each character in this we have checked corresponding, right, in the sequences order, right? And if any of the character is mismatch, we were updating the dist array, right? Distance variable, and finally we are returning the dist count, right? Because that will give you the Hamming distance one. So if the Hamming distance function is returning equal to 1, it means all these three rules means the group should not be equal, the words length should be equal, and Hamming distance should come to 1. All these three should match, right? Now we will check dp at j plus 1. If we will do dp at j plus 1, it should be greater than dp at I, right? So what we are trying to do here, that we will understand, right? Let me first go through the code. So dp at I is dp at j plus 1. If these three condition matches, then what we will do, dp at j plus 1 we will assign to dp at I. And because we are checking the length, if it is greater than this, it means we have got the longest sequence, and so the longest sequence till here, it should be updated like this, and the previous indices we can store like this. Okay, then we will complete the if condition, then we'll complete the for loop, and then we'll complete this indices, right? So what we have done here, first of all, we have gone through all the 0 to n indices, right? And for each character, right, we have to go to j is equal to 0 to j should be less than I. What is I? I is a word, number of words. So all this is like, let's suppose I is 0 to n, means how many words are there. For each word we will make another for loop. This is for all the words. This is for single word, right? For single word we have to check for each words. We have to check what their groups at I should not be equal to this. The words length at I should be equal to words at j, and the Hamming distance between these two words should be equal to 1, and dp at j plus 1 should be greater than dp at I here. And then if this is the condition is there, update the dp at I from the dp at j plus 1, and you store the previous indices, right? So we are comparing word I with all the indices of j, right? We are comparing all the I with all the j, right? So to do that, we are making two for loop. I, for all I, we are going with all the previous j, right? So if a valid transition exists from j to I, we are trying to extend the path ending at j by adding I. Understood? And we only take if its result is longer. If its result is longer, we'll update it, right? So understand, right, what we are doing here? We are storing the length of the longest valid subsequence that ending at I, right? Ending at index I. And we are previous at I, what we are doing? We are storing the previous indices in the longest path that we have found at index I, that is called j. It will help you to construct the sequence, right? I hope you understand, right? Now think about the longest subsequence that ends at index. How we are going to find? So let's understand. Find the longest subsequence that ending at index, right? So for that, what we need to do, we'll define two variable. Let's suppose max length and end index, right? And then what we should do, we should go for all the indices, all the words, right? And then we'll keep track of dp at I should be greater than this max. And if the dp at I is greater than this max length, what we will do, we'll update max length is equal to dp at I, and then we'll update and index is I, right? How? So we'll go for all the for loop, right? For loop I at 0 to n, then we'll check if the dp at I is greater than the max length, then we'll update the max length, and then we'll update the previous index and index at I, right? And then we'll find the longest subsequence sequence and index. Like this we will find. After that, we should reconstruct the path using the previous array, right? So how we are going to reconstruct the path using the previous array, right? So we'll create a linked list. We'll create a linked list and to reconstruct the path using the previous array, right? So first of all, we'll define the linked list result equal to new linked list. Then we'll check while and index is not equal to -1. Then we will add the word index that at last index, right? Means we will result dot do add first, and we'll add the words at end index, right? And finally we'll also update our end index is equal to previous at index. So you will have the end index. So this loop will keep until the end index is not equal to -1, right? So we are what we are doing actually here, we are starting from the index with a longer sequence, right? And how we are going to do that? So we'll check, we'll keep going with the we'll keep going back using the previous index at I, right? So until you reach the start of the indices. So this is the start of the indices, right? Until you reach to the start of the sequence, okay, then we'll go there, okay? Until that we have to go there and we have to update our result. I hope you understand, right? what needs to do, like what is the intuition and the approach. So first of all, we will understand the constant, we'll check all these conditions to do, right? And then we will build the full graph. We will not build a full graph, we will create the transition in place to save in the memory, right? Then what we need to do, we have to define the helper method to calculate the Hamming distance. As you know, we have created a Hamming distance helper method, and we'll check between the two words, right? Then we will set up the dynamic programming DP, and we'll define these variables, and we'll initialize these DP arrays, right? Then we will simulate the graph with the nested for loop like this, and we'll avoid building the full graph, right? After that, we will find the longest subsequence that ends at index, that we will do, and finally we'll reconstruct the path using the previous array. So let's go to Leetcode editor. Is the font, right? And as you can see, first of all, what we need to do, we have given the class solution, and we have given this method, right, where we have given words and group. You have to return the list of string, right? And for that, what you need to do, first of all, you will define all these things, like you can write the number of words, then DP, and the previous array. You have to fill like this, as I told you, right? Then finally, what we do, we'll create a DP without we don't need to create the graph, right? So for that, we'll go for all the indices, then we'll go for all the j, right? And we'll check if these three conditions are matching or not. The first we'll check group should not match, words length should be equal, Hamming distance should be 1, and the DP at j plus 1, right, it should be greater, DP at j plus 1 should be greater than DP at I. If that is the case, we'll update the longest one, and we'll keep track of the DP and previous index, right? Then finally we'll find how we are going to find the index with the DP value. So find the index with the max DP value, we'll get, so max length you will find, and for that you have to traverse for all the indices. You will check DP at I should be get the max length, and then we will find the max length should be equal to DP at I, and then the index, last index, right? Finally, we'll construct the path. How we are going to find the construct the path, right? To reconstruct the path, you have to create an array, linked list, and we'll check until the sequence not reach to the start. Till that, we'll keep adding into the result and update the index, and finally we'll return the result, right? I hope you understand, guys, right? Say time and space complexity. So if you talk about, we are going for the two loop, right, nested for loop. So we are going with the O of n, you can say given words of length n, right? So if this is the length of the word, right? So what we need to do, let's suppose the average words length in this word, like this is the array of the words, there is multiple words in this one, right? So each word having the size m, right? So what we can say, so O of n square for this, and O of into m, you can say O of n square into m, we can say the complexity. So if you write here, time complexity become O of n square like this, and we can multiply with the number of words, right? M is the average word length, okay? And for a space complexity, we are taking to store these values, right? So it will take O of n, right, like this, okay? Thank you guys, thank you for watching this video. I hope you like this video. Please hit subscribe this channel, and please support Expert Panda by subscribing and liking this video.